the Google form was supposed to be just really quick. Hey, I listened. These are the right answers. A couple people missed a few of them. One of them I get why some people missed, but I just want to talk through them really quick. Which of the following is not an acceptable value of R? R can be all the way from what to what? -1 to 1. So negative numbers are fine as long as they're less than -1. 1.2 is not, would not work. What kind of variables can make a scatter plot? When you make a scatter plot, each axis is literally a what? A number line. So how can you make a number line with categories? You can't. So they have to be quantitative, not categorical. A negative slope, everybody got this one right, it means that as one increases, the other one decreases. Now, just because I always have people who, easy concept, but if I ask it in a different way, some people get confused. Right, that was obvious. What? If instead it is a then what? So the positive negative slope really just means direct correlation or indirect. A negative slope means as one does one thing, the other one does the opposite. A positive slope means as one does one direction, the other one also goes the same direction. When I ask that in a different context like this, sometimes people are just not thinking about it. R will always have the same positive negative value as slope. Slope literally goes, it's going this way, it's positive. It's going this way, it's negative. R has that same idea. Why is that not the case with R squared? R squared is always positive because anytime you square a number, you're going to get a positive number. And y-intercept doesn't relate to either one of those. This one, I get why people mix it up. The correct answer for what is another word for R is correlation. This one instead is your what? R squared, I was kind of surprised that this many people missed this one because I said this is the only thing you need to know about this entire problem. R squared is always the percent of variation in y. And you're predicting y, so it's how much your prediction varies. That's why it's y and not something else. This one, I think it was this one. This one was the most missed, and I get why people missed this one. I think people thought this was more complicated than it was. My explanatory variable was number of apples sold. I got an R of 0.3. Each apple sold for $2, so I changed my explanatory variable to, instead of being number of apples sold, I changed it to my dollar amount made from my apples. So all that I actually did was this, which means I transformed it. My axis that did look like whatever my dots look like, all it does is switch these to be.
Wait, does it not matter because even if you change the units and stuff, the points are still the same? Like the graph still looks exactly the same? Oh, okay.
So I get why people miss this one. This is a good problem to go over. You can see what I did here. I didn't actually change the graph. I just changed the scale that these were on. So transforming one of your variables doesn't actually change your R at all. And then a scatter plot shows a perfect curve. Keyword there. Why does R not necessarily equal 1?
Because R is linear.
Because R measures linear. So definitely it's not yes. Here, I get why people did this because you don't know if it's positive or negative, but R doesn't measure curves, it just measures a linear relationship. Questions on any of those? I kind of liked that homework. Doing a really quick one like that with really key points. Now that we're at the end of the semester, I really liked it. Should have done that more often.